Hi, Professor. My name is Harshit Agarwal, and today, me with my team is going to demonstrate the final presentation for the language which we have designed and implemented, and we have named our language as Sparky. So, coming to the table of contents, we are going to cover the key features which we have implemented in our language, the flowchart, design, DCG rules, sample program, and finally the demonstration of our project. Now coming to the Sparky features, we have implemented primitive data types like integer, boolean, string. We have support for logical operation like AND, OR, and NOT. We have other support for arithmetic operations on the data types like addition, subtraction, multiplication, and division. We have support for assignment operator as well as if and else conditional statement, do and while iteration statement, for and for and range statement, ternary, and so on. Some other features which we have implemented in our language are we have support for relational operators like equal to, not equal to, greater than, less than equal to, and so on. We have support for other parentheses and curly braces in our expressions. And we have made sure that the precedence and the associativity rules is followed throughout our project in our grammar. Now coming to the flowchart, so the it contains the source code which has the extension as .s5, which is short form for Sparky, which is given as input to the lexical analyzer, which we have written in Flex, and the list of tokens which is generated by the lexical analyzer is given as an input to the parser, which is written in Prolog in our case, and the prologue on success will generate a pass tree which is given to the evaluator, which is also written in prologue in our case, and finally the evaluator will generate the final output.
Hi, this is Aditya Desai. So Harshit just explained how the code of Sparky is flown through the compiler and how the code is generated into tokens, and how they will be generated in tokens and different components, and how the final output is done is the flowchart of the entire Sparky compiler. And there are different components in it. And before we actually dive in these components, I want to talk more about Sparky itself and what exactly are the features of Sparky. So he did tell you that Harshit did tell you about different features like the command sugar and um, how what the command sugar is, how the expressions are, what exactly are data types. So let's dive into more into that. Let's go into how Sparky is actually built in. So it is actually committed in the GitHub. The grammar of Sparky is committed in GitHub, and you can check it out directly. The link is mentioned over here. So what we have different components in the Sparky language. So one is it's programmed, what are different blocks that are there. The block can be declaration, commands, and everything. The entire BNF is present of in the file. The finally what is basically is the program starts with the main and the BK block. And the block is basically it can be a block of declarations, a block of commands, block of declarations and commands. It can be combinations of both. So what have we done is we have in commands what changes the environment. We have included do while loop, we have included while loop, we have included for loop, the for in range loop, and if else statement. We've also included data types that are three: integer, boolean, and string, and the arithmetic uh, expressions in them. The associativity and the precedence is managed in the DCG using operands, and this different labels are there. Like a expression becomes into task, a operation becomes into a task. So that is always mentioned. That is more explained by my friends and teammates in the head slides. And we have included Boolean expression comparison as well, like not equal to, less than. What is one of these are the one of the features that are there. The one more feature is command sugar, like an int plus plus and a minus minus. Then the BNF is expressed in two forms. It was a left recursive grammar, so we have removed it using substitution. And in prologue ahead, we are gonna use remove it using tailing. So a part of command or DCG is pasted in the slides itself. The DCG is more evolved into evaluator including because we've done both in Prologue. So the final file is a bit jumbled together. So a cleaner and a starting initial part of it is explained here. You can check it out. So what I was talking about expression, and expression becomes an arithmetic expressions become a term can become an operation can become a task can become a command sugar. That all is explained. Not the entire DCG is given in, but this will be more clearer in ahead of slides when we go into evaluator, and my teammates will explain into that. That's it. That's from my side. That's what I worked on, the grammar and the DCG part, and my teammates will explain more ahead. Thank you.
Hello, my name is Aditya Krishnan, and I'll be presenting the lecture and the flow of the Sparky programs to you. So in our lecture, we have used the Flex software to implement our tokenizer, and we have tokenized our parser in such a way that it could actually manipulate the incoming source code into the required format we needed for the parser. For example, if we needed to remove quotes from a particular variable or identifier or any other string and replace it with something else so that the parser understands it better. So we do that in the tokenizer in the lex file itself. And as you can see, we have a bunch of keywords that we have allowed. Other than this, any other word would be ideally considered as an identifier or a string if it's inside double quotes. And along with that, of course, we have also extracting special characters, which are all the symbols required for operations such as logical and arithmetic operations. So I could just show you the file. This is our lecture, which is inside the lecture directory in src. So our lecture is using the regular flex source commands, such as we have defined the keywords, the formats for extracting strings out of them, the format for extracting other keywords and other operators, and of course for identifiers as well, we are using regular regexes, but we want them in a specific input, such as in between double quotes for the parser. So we do that here itself, and then we pass these to the compiler. Coming to how Sparky essentially works, we are tokenizing and compiling in a single file known as compiler.py, and the compiler actually generates an output file which is .syc, which is Sparky compiled, and it makes use of Flex to tokenize and Prolog to generate the parse tree. So this is the example of how to compile a particular file, and I could show you this code. So essentially it's a script, and essentially we just take the output from the tokenizer and the parser and store it in a file. So let's start. We have made an sh file as well to help us along the process because we wanted to execute a bunch of commands in a single line. So all we do is take the file name as the input and pass it along to the bash file, which then runs the lecture upon it, and the output is stored in a file named as aout, which is of course a temporary file. And after reading the output from that, we essentially run the parser upon that result, and whatever the parser has generated, which is essentially the parse tree, we will be storing them into another file with the output of syc. So it's a very simple process. We just pass it to the tokenizer using the script file, and whatever the output is from the parser, which is the parse tree, we'll store it in the syc file. And for the interpretation part, we use runtime.py, which is our evaluator essentially, and we in its raw state, we provide the parse tree to the runtime.py. I can show you, and all it does is again run the evaluator upon it, which is again written in Prolog, and the output is straight up printed in the terminal so that you can see the output. And for all complex programs, it will just print the output as you wanted it. So that's it. Thank you.
Okay, so hello everyone, this is Ujla. I worked on the evaluator along with Ajitesh. So our evaluator has been implemented in Prolog, and yeah, the reason for choosing Prolog was because we have already been studying Prolog our whole semester, and after researching it, Prolog seemed like a good idea to work on the evaluator with. So yeah, this is just one screenshot of the code that we have written for prologue. If I go to this link, so this is the link for our evaluator code. So as you can see that this is the first predicate with which our actually evaluator starts. It first gets the tokens from the tokenizer, and then the TCG or the parse tree from the parser code, and that code is actually sent over here in the eval program. This program T is actually the parse tree, and environment is that one functionality that we have executed in order to make sure that scope functionality is taken care of. And yeah, so as you can see here, we have from the program, the function goes, the evaluator goes into block. Block is either a declaration or a command, and after that we have the loops. So yeah, so yeah, the commands can be a loop or command sugar. So command sugar is basically a plus plus, a minus minus, a plus equal to, and a minus equal to, and it can be some kind of an assignment or a print statement. And yeah, so as you can see, this is the part where we have implemented the command sugar part. And now when we come to the loops, so we have implemented do while loop, while loop, for loop, the traditional for loop. We have also implemented the for I in range loop. So the for I in range loop also has another functionality, that is the stepper function. That is it just not takes only one, like it increments by one. We can also specify the value by which the function the variable has to be incremented. And yeah, so, and of course then we have the traditional if else loop, if else condition. What we also have here is the ternary operator. So yeah, here it is. So the ternary operator works in our code. It works with Boolean and arithmetic variables. So yeah, with string variables we haven't implemented it. And yeah, these are all the Boolean expressions. Basically, like we can evaluate, like we have implemented the not, or we also have the logical and or less than, greater than equal to, less than equal to, and yeah, pretty much that's it. So a little about the environment that we have implemented. So in that, what we do, we also have taken care of scope while declaring variables or changing their value. For example, if a variable has been defined in the if statement, then its value cannot be updated, or it cannot basically be accessed outside the if statement. So now I'll be handing over to Ajitesh for explaining the sample code.
Hi, I am Ajitesh, and I worked on the evaluator part of the entire project. So first, let me show you some of the sample programs. So here is an implementation of a do while loop. As you can see, A is initialized to 0, and it increments every time B decrements, so A gets the value of B. Here's another program of for loop. So although we were expected to implement only the range from start point to end point, we also decided to go ahead and implement the step functionality along with it. So as you can see, the loop goes from 0 to 10 in a step of 2, and A starts from 0. So the value of A after the program runs is 5. Here is a little bit of usage of command sugar here. So we have implemented the increment, decrement operators as well. So if you go through the code, the answer will come down to 6. So other than normal programs working, we have also implemented the error handling as well. So as you can see here, the variable name is and I am trying to assign a value to ANS variable, which is not declared anywhere in the program. So it gives me an error data. Yeah. Then other than that, yeah. So for Brownie features, the features that we were not expected and we decided to implement it were scope variables. So basically, whenever you declare a variable within an if condition or within a while block, it is not accessible outside the block. We wanted to use this functionality and implement the functions as well, but because of time constraints, we couldn't do that. Then we have implemented command triggers like plus operators, plus equals to operators, and all those stuff, which you can find in the documentation. Then we have also implemented Boolean and Boolean or operators. This step function in the range, for loop range, and a little bit of error handling as well. So let me go ahead and show you a program that I have already written in Sparky. So in this program, I have used most of the features like for loop, for in range, while loop, if else condition, then ternary operators with a Boolean expression and all those things. So I'm just going to run this program here. As you can see, it prints out all the values of variables after each step. So other than the for loop, for normal operator, for in range operator, we have also implemented the traditional for operator, which you can find in the documentation.